Hi there. Thank you so much for joining us today. My name is Adrian and I'm your coach for today. Today we'll be covering the topic of fuzzy duplicates, which is available in ACL Desktop 9.3 and Analytics 10. I've been with ACL for just over 3 years now as a consultant, and I've helped a lot of my clients develop data analytics programs. I've also been an auditor at Ernst & Young, and I am a certified management accountant. Today, our guest speaker is Kevin Legere. Kevin, why don't you tell us a little bit about yourself?
Thanks, Adrian. My name is Kevin Legere. I've been with ACL for almost 3 years now. I've worked as an implementation consultant, and before that I was on the support team as an escalation analyst.
So many of you folks may have actually spoken to Kevin on the phone when you had an issue.
If you have, I hope that I helped you solve your problem.
I hope so too. So let's talk about how fuzzy duplicates, or the fuzzy duplicate function actually works within ACL. Where can you actually use fuzzy duplicates? It works within one field, and it's really good for analyzing potential duplicates in the name field, for example. So if you've got a vendor master or an employee master, you can start looking to see cases where names or addresses may be similar. Now, the actual theory of how the fuzzy duplicate function works within ACL, that gets a little bit more complicated, and Kevin's going to explain that to you.
So ACL uses an algorithm called Levenshtein distance to determine whether something is a duplicate or not when performing fuzzy duplicates. How Levenshtein's distance works is it looks for the number of single character edits required to make two strings match each other. What that means is anytime you need to add a letter, delete a letter, or substitute a letter, that counts as a character edit. So I included some examples here below. The first one, Adrian versus Hadrian, we would need to remove the H from the second one in order for it to match the first one, which would give us a Levenshtein distance of 1. Pretty simple, right? The second example, we have the male-female version of Adrian. We would need to remove the N and E from the female version and also change the first E to an A for it to match the first string. This would give us a Levenshtein distance of 3 because we had to make 3 character edits. After that, we can see a couple examples where they don't really match up at all. Adrian versus Kevin, the only letter that matches is the N, and so we would need to make 4 edits for them to match. And then Adrian versus Peter, which have absolutely no letters in common, you would need to make 6 character edits for those strings to match. So that's kind of how Levenshtein distance works.
And what ACL will do is it will take the minimum number of changes necessary to make one string look like the other.
That's correct. And then the other parameter that's important when doing fuzzy duplicate analysis is something called difference percentage. The way ACL calculates this is it takes the Levenshtein distance, which we just talked about, and divides it by the number of characters in the shorter string, and multiplies it by 100% to give you a percentage. We'll see how that works a little later on. And fuzzy duplicates, I think as Adrian already mentioned, is available in ACL Desktop 9.3 or higher.
Right. So let's actually take a look at some data and see how this could actually be applied. So what we have here is the employee master table, which includes the fields the personnel number, the name, the street address, the city, and lastly the country. Let's start by just kind of going through the table to see what potential duplicates we're expecting to see here. So we're just going to start by sorting it on the name field.
So there's 2 ways that you could sort on the name field. You could either sort on the name field to a new table, or you could use the handy feature of quicksort ascending.
So we can see here in record 3 and 4, we're seeing Akeem Fisher and Akeem Fisher, but there's a slight difference. There's a C missing from the last name, but the addresses are identical. So we know that even though these are not exact duplicates, this is a potential duplicate that we're expecting to see when we do the fuzzy duplicate match. Now I know from combing through this before that I'm also expecting to see Albert, let's see here, I can't pronounce his last name, but you can see here that the name again is slightly different. We're missing an I, the first I in his last name, but if you can see the address field, it's slightly different. One has ST dot and the other one has the word street actually spelled out. So we're going to also expect to see this one when we do a fuzzy duplicate. I also know that I'm going to expect to see a Christian Nelson. This was one that was brought to my attention when we first got this file. And here we can see there's a Christian Nelson and a Christian Nelson Jr. So we're going to hopefully see this one when we do a fuzzy duplicate as well. And lastly, there's a Michael David. This one was also brought to my attention. And we're going to expect to see this one. It's a little further down.
You're making me do some work here.
That's not so bad. So we have Michael David here. But I also know that there's going to be a Michael. Sometimes they may have entered it in the system with a middle initial. I'm going to expect to see this one here as well. So let's just keep an eye out for this one later on when we start looking at the results. So let's just start. Our approach here today is going to start off very focused. So we're going to start by doing a straight duplicate analysis on the name field first, so we have the exact matches. Then we're going to start to cast our net, so to speak, a little bit wider by expanding using the Levenstein distance parameter by increments of 1 to see what results we get and to see if we actually get these matches showing. And then afterwards, if we find that it's too much, we'll dial it back in. So let's start by using the duplicate function on the name field.
Alright, so first off we're going to use the old school, kind of just looking for straight up duplicates under Analyze Duplicates.
An oldie but a goodie.
And we're going to do duplicates on name, and we're going to include all the other fields. And always make sure to name your table something so that you know what you did later on. So I'm just going to call this table T_exact_dupes.
Yeah, it's really important to keep the names in a or to name your tables something that makes sense and that's logical. As you'll see when we go through this exercise, we're going to come up with a lot of tables that are just slightly different, the parameters that we entered. So we want to make sure that we name it with something that will tell us what parameters were used so we can keep track of all these different tables. Alright, so what we have now are all the duplicates from our employee master table. And we can see, okay, this is interesting. So we have Andreas Klein, 2 different personnel numbers, same address. So that's a good find here using using the duplicate function. And we're also seeing Axel. How would you pronounce that?
I'm sorry, I don't want to massacre this.
Okay,
person's
I'm just
last
gonna.
name.
Okay, we'll just keep him as Axel.
Can we call him Axel J?
Axel J. All right. So Axel J. Again, we have the same address for this Axel J, but different personnel numbers. So we have 2 unique records in our employee master with this person's name. Same for Colleen York. We have a lot of duplicates here. So this is a really good find. Now let's cast our net a little bit wider and use the fuzzy duplicate function. We'll start by using certain parameters first, and we'll expand that to see what additional potential matches using the fuzzy logic we will get.
Alright, so the fuzzy duplicate command, new in ACL 9.3 and Analytics 10, can be found under Analyze right below Duplicates. So we're going to open that up. We're going to do fuzzy duplicates on name. For now, we're going to do a difference threshold of 1, which is our Levenstein distance. And just for the purposes of our first test, we're not going to include percentage difference or result size. We'll get to those a little later. And you also have the option to include exact duplicates. For now, we're not going to do that either. We already have a table that has our exact duplicates.
But if you later on wanted to have all your results, so your exact matches and your fuzzy matches in one result table, you're going to want to check off the include exact duplicates checkbox. Alright, so what do we have here? So you can see that ACL will actually give us a few extra columns. They'll give us a group column and also a group number column, which can be used in the future if you accidentally sort it on the name field and then you lose the grouping of it. You can sort it on the group number in order to get all the groupings again. And each grouping represents a pairing or a match based on the Levenstein distance parameter and any other parameters that you enter in there. We also have the original record number, which tells us which record number it resided on the originating table. So our employee master in this case. We also have our personnel number, our street address, city, and country field. So we're starting to see some interesting results here. For example, Aaron McKee, in the first case, they had 2 A's in the first name, but in the second match, it only had 1 A because it was spelled differently.
And we can see that both Aarons live on the same street in the same city. So it could potentially be a good match.
That looks like a good match. And then we also have Akeem Fisher. Again, so this one we were expecting because when we did a sort, we knew that we were going to expect to see this. So this is a good find here as well. We know that the function is working properly. However, what we're not seeing here are some of the other ones that we were expecting to see, such as Christian Nelson and Christian Nelson Jr. That match did not show up here. And also Michael David, where we knew that in their second matching record there would be a middle initial. So let's expand the net yet again and change the Levenstein distance to 2. So now we're going to be expecting to see at the most 2 necessary additions, removals, or changes in order to make one string look like the next string.
Right, so we're going to redo the same analysis, except this time we're going to have our difference threshold of 2, which again is our Levenstein distance, and we're going to include all the fields and name our table something appropriate.
Alright, so now we actually got more results. We have 92 records of potential matches here. And we can see that we have the same ones that we had before. Aaron McKee, Akeem Fisher, Albert A., which we're not going to attempt to say his last name. What else do we have here? Okay, we're starting to see some false positives here. So for example, grouping, let's say 380, we have David Johnson, David Lawson, and David Parsons. So these are clearly different, and we can confirm that by looking over at their address. Yeah, they look like they're different people. But we are getting some interesting results here. Let's see here. If we're looking also for the ones that we're hoping to find, which included Christian Nelson. Did we find that one here?
I can see here we found one with a middle initial. We have Michael David and Michael T. David.
There we go. So we have a good match here because they have the same address, and in this case it accounted for the initial in the middle of the name. But we're still not seeing the Christian Nelson and Christian Nelson Jr. So let's go one step further and again expand our net, so to speak, and use a different Levenstein distance.
So again, we're going to do pretty much the same analysis, except as Adrian said, going to cast the net a little bit bigger and do a Levenstein distance of 3. See what kind of results come out.
And what we're hoping to do right now, as we kind of slowly expand it, we're trying to find that sweet spot where we have an acceptable number of false positives, but also good matches. Alright, now what do we have here? So we have over 450 results. That's a lot.
I have a feeling there's going to be way too many false positives in here, and no one likes to go through false positives.
I agree. I mean, if we look at just group number 7 right here, we've got Adam Miller, Pat Miller, and Tom Miller, who all live in different places. So clearly, we're getting a lot of false positives here. So maybe we've kind of overcooked this one a little bit already.
Should we now try to include the difference percentage to see how we can trim down our false positives?
Yeah, let's do that. Why don't you walk us through how to do that and how it works?
Sure. So we're going to go back to our employee master table and basically do the same analysis, but we're going to add in a new parameter. So fuzzy duplicates on name. We're going to keep our difference percentage or difference threshold at 3. And difference percentage, if you remember from before, is the Levenstein distance or difference threshold divided by the length of the field. And so we're going to cast this at 25% to start off and see what kind of results we get.
So another way to look at this, the percentage difference, and it took me a little while to wrap my head around it, is that if we have 2 strings that have a Levenstein distance of 3, the minimum length of the shortest string that we're expecting to see is 12. And so this will actually prevent us from finding cases where the difference was 3, but the strings were really short. Maybe they were only a length of 5, which is a huge percentage of the entire length of the string. So this is what the percentage difference prevents from happening.
And I'd just like to add in, generally what we found is as you increase the difference threshold, it's really good to decrease the difference percentage. And that will make it so that you need longer strings in order to get the match on the Levenstein distance.
Agreed.
So I'm just going to click OK here and see what kind of results come out.
All right, so we are actually seeing here now just under 250 records, which is better than we had before. And if we scan through the results, some of them are good. So the first group 2 and group 4 are good. We're expecting to see those. Group 17, Alan Williams, Anna Williams, John Williams. Those look like some false positives. So we're kind of getting an interesting mix here. Let's try tightening up the parameters a little bit more. Using the percentage difference, we'll tighten it up a little bit more and see what we get.
Yeah, so maybe we had the difference percentage just a little bit too high. So let's try lowering that just a little bit. So again, fuzzy duplicates on name, if you're not bored of doing this yet. We'll set our difference percentage to 15 this time.
Sounds
Does that
good.
seem like a good amount? Oh, it seems like we have a few less results now.
A lot less results. We've got 28 records here. So this is good. We're heading in a good direction. However, I think we might have overdone it with that particular one because we're no longer seeing ones that we're expecting. For example, a Michael T. David and Michael David. We're not seeing that here. Nor are we seeing the Christian Nelson and Christian Nelson Jr.
Right, so we might have taken the difference percentage down just a little bit too far.
I think so.
We do have a good one here. I like this one. Carl Manuel Espinoza and Carlos. So that's a pretty good finding.
That's a good finding.
All right, so maybe we should try increasing the difference percentage. What do you think, back up to 20?
I think let's try 20 and see what we get.
All right, so we'll go back to our employee master table, rerun the same analysis, but this time we're going to make the difference percentage 20 as opposed to 15.
Alright, so we have 87 results. Now scanning through these results, they actually start to look, this looks about right. I mean, we do have group 2, 4, 18, these are all good results that we're expecting to see. We also have, if we look at group 263, we see the Christian Nelson and Christian Nelson Jr. that we were expecting to find. If we go down a little bit further, let's see if we have that one. Michael David and Michael T. David, so this is good. We know that we're getting ones that we're expecting, and then we also have some false positives. However, I think these ones are pretty acceptable because 87 records, that's not too many to go through, at least for myself to go through. I'm all right with the false positives, knowing that we're getting good results in the other cases.
Yeah, and I think it's important to remember anytime you're doing any sort of fuzzy analysis, you should always expect there to be some false positives that you have to go through. I mean, that's what fuzzy analysis is all about, really.
Right.
It's matching similar, not the same.
Right.
But yeah, this seems like good parameters for our data set.
Yep. The parameters that we're using here is not a one-size-fits-all. So you're going to have to tailor it for the data set that you're working with. So start off like we did, start off focused, and then slowly expand that net to see what results come back. And then if you need to, you can bring down that net and cast that net a little bit tighter to fine-tune and find that sweet spot for your data set. Now there's one more parameter that we didn't talk about yet for fuzzy duplicates, and this is for the cases where you're not really sure how many results you're going to get back, and you don't want your system to sit there or your computer to be taken, like the resources to be taken all afternoon, unless it's a Friday afternoon. So what you can do is use the result size percentage parameter to restrict the size of results that will come back. Kevin, can you talk to us a bit about that?
Sure. So when you're doing fuzzy duplicate analysis and you're matching similar stuff, especially in the beginning if you're casting the net kind of big to see what kind of results are coming out, you may end up with, especially if you have a big data set, millions of results. And it could take a long time for the analysis to run. If you want to kind of get a quick result and see what the first X number of results kind of look like, you can restrict the size of your result table by using this result size parameter. And what this does is it'll restrict the result size to a percentage of your original table. So for example, the default is set to 10%. So if you had 1 million records in your original table, it would restrict the results to 100,000.
I think that's what my math in my head says as well.
I had to double check there for a second. And so we left this off because we were working with a fairly small employee master table, and so we weren't too worried about our result size. But this may be something you want to include when you're doing your fuzzy analysis, especially if you're working with very large tables.
Or it's the first time you've seen your data and you have no idea what kind of results you're going to get back.
Yeah, that's the other thing. When you're doing a fuzzy analysis, it's going to look for a match on every other field in the table. And so you could exponentially make your result table bigger than your original table. So it's a good parameter to include the very first time you're kind of running this analysis. Especially if your Levenstein distance is a little bit higher, you'll have a bigger net to cast.
So let's summarize what we learned today and try to come up with some good practices. Let's start by talking about harmonizing the fields that you plan to do the fuzzy duplicate analysis against. We recommend that the fields that you're going to be working with be harmonized first. So for example, if you're going to be working with the name field, make sure that the order of the names are consistent. Last name first, maybe a comma, then a first name, or a first name space last name. If they're mixed up and they're not consistently formatted, then the Levenstein distance between the two in order to make them match will be much higher. Also remember to try to, if it's possible, remove any abbreviations or keep your abbreviations standardized. So in cases where we have ST and STREET for street, the Levenstein distance between those two strings is 3. And you're going to not see that come up because the abbreviation is different. And also, if possible, and this is pretty simple using ACL to do this, remove any special characters such as spaces, commas, dashes, and periods. Again, if there's ST dot and STREET, or sorry, ST dot and ST, one Levenstein distance is wasted on removing the dot to make ST look like ST dot. Also, start with very focused parameters. So in this case, what we did today, we started off with a straight duplicate test, then we expanded the net a little bit by using the Levenstein distance of 1, then 2, and then 3. And that's when we started to notice that we were overcooking our results, so to speak, and coming back with a lot of false positives. So start small and start focused.
The next thing to remember, which we have found has worked really well, is as you increase your Levenstein distance to kind of cast that net bigger, make sure you decrease your percentage difference. This will help you get more valuable results and spend less time going through false positives. And lastly, it can be really good to combine multiple fields to reduce false positives. For example, in address, you may want to include the zip code, and that can help you kind of get better, more valuable results.
And so that's pretty much all we have to share with you today. Do check out the ACL blog for Phil's Top 25 Test Series, where our product manager, Phil Lim, shares his ideas of what are the top 25 tests that he's seen with our clients. Thank you so much for joining us, and Kevin, thank you so much for taking time out of your busy day to come and join us and our viewers to talk about how to use the fuzzy duplicate.
Yeah, thanks for having me, Adrian. It was fun.
Awesome. Until next time, take care.